linear inequalities. We will be able to solve systems of linear inequalities by graphing inequalities and write the equations for it. Some vocab to start. System of linear inequalities. This is very similar to systems of linear equations, which is what we have been working on. So we have solved systems of linear equations by graphing, substitution, and elimination. Today we are working with inequalities, so they are a little different. Our inequalities involve these signs, where our linear equations down here involve the equal sign. Okay, so there are two or more linear inequalities together. Solutions of a system of linear inequalities makes each inequality in the system true. So once again, this is not different. Before, we were looking for an order pair that made both equations true in the system. So a solution to a system of linear equations, we were trying to find an order pair that made the two equations true. Now you're going to be given a linear inequalities, so you're still going to have your two equations, but they're going to involve an inequality, which once again is one of these signs instead. And there is going to be something a little different today. Instead of looking for an order pair like we have been, what's going to happen with inequalities is you're going to shade two different regions. So if this is very quick overview. We will get into much more detail, but let's say I have a graph or a line, an inequality that creates this picture. This is my shaded region. Alright, and now I have my second, let's say I'm going to graph this second equation, which you don't even know. I'm just kind of giving you a quick overview here. Let's say it creates this line. And it's going to be graphed here. So now I have two different lines graphed on here, and I know this seems really crazy. We're going to use different colors here. And I could even use a different color right now. I use a different color to represent this line here. This is the shaded region. What it says is the shaded region that have both inequalities have in common. So we're looking for the overlap today, because this overlap, which we can see is roughly here, this shaded region here in blue, well now green because it's an overlap of course, is going to be your solution. So any order pair that's in this shaded region is going to be a solution to these inequalities. Okay, so we're still solving, we're still graphing, and then you have to shade it. You're using yesterday's lessons of shading, and you're trying to find that overlapped area. So that was a lot of content. So if you need to rewatch this video, I do encourage you to rewatch this first 5 minutes. So a little more explaining of what I've been talking about. So here we have a shaded region. This first inequality here is x is greater than equal to 3. So here x equals 3. It's a shaded solid line because it's an equal to. Now I pick a point. We test 0, 0 yesterday. 0 greater than equal to 3. 0 is not. So you can see this pink region here has been shaded in. Look at my other inequality. Y less than equal to -2. So we treat it as y equals -2 right here. And it is a dashed line because it is just greater than, less than. Check your point, 0, 0 again. Is 0 less than -2? Is not less than -2. 0 is greater. So since 0 is not a solution, once again they shade below the line. Because, so let's test a different point. -5 here. Is -5 less than -2? Yes, it is. So you can tell they've included -5 in our solutions. So remember, an important key part for today is the shaded region is identifying all of the solutions to these inequalities. We no longer have like one order pair that we are looking for. You are going to be shading regions in the entire region that overlap. So here we have that lavender mark right here. I'm really shading in. This is the overlap area. This area is what makes both inequalities true. So any order pairs in this solution will make these two inequalities true. Overlap here. So this is just a completely different problem. So you can almost ignore this area and just focus on this top part here. So the first thing we do here is we pretend like this is really y equals -x plus 3. You guys know how to graph this line. So y equals -x plus 3. 3 is where it's going to cross my y-axis with a slope of -1 over 1. So 3 is where I cross my y-axis, slope of down 1 over 1. So as you can see, it follows this line here. They have made this a dashed line because it is not equal to. Okay. Now, just like yesterday, we have to figure out where to shade the region. So pick a point. I'm going to pick 0, 0 because I like that point to pick. So if I plug in 0 here, 0 equals a -0 plus 3. This is going to give you 0 is less than 3. Is 0 less than 3? Yes, it is. So I will have shaded region. I will have shaded this region because this is a solution. Alright, this different blue and pink gets, or blue and red, the way they have it shaded is a little confusing because they have the overlap in here already. But as long as you understand that this is the area that is shaded, we're in good shape. Okay? So now, let's 2x plus 4y is greater than or equal to 0. Here I'm going to add my 2x. So I get 4y greater than or equal to 2x divided by 4. Y is greater than or equal to 1/2 x plus 0. And the 0 is not there, but you do need to know that. So the first point is going to be here at 0, 0. Because it crosses at 0 with a slope of up 1 over 2. So I go up 1 over 2, up 1 over 2, go down 1 to the left, and it creates this line here, which is not very straight. Is that black line that we started with. Plug in my points to figure out which way I shade. Usually I like to plug in 0, 0. However, this goes through 0, 0, so I cannot pick that. So pick a different point. I'm going to pick right here, -2, 1. Okay, so I got to decide if I'm shading on this side of the line or this side. So right now I'm testing -2, 1. So let's test -2, 1. Plug in -2 here. 1/2 times -2 is going to give me a -1 plus 0, and I'm going to get 1. Is 1 greater than or equal to 0, or greater than or equal to -1? Yes, it is. So that is true. So that means this is a solution. So that means I need to shade this way, which you can tell they've already did. However, they did not include the overlap. So they're trying to make this, the overlap, easy to see here. So as you can see, I'm shading in this whole area Okay, so I've shaded this whole area. Now, the point of today is finding where we overlap. Okay, and as you can see here, I'm going to highlight here in yellow our overlap area. So this overlap area is stating that anywhere, any ordered pair in the highlighted in yellow area is a solution to this inequality. Okay, so this next part is they're saying, alright, is negative 1, 1. So right here, is this a solution? Does this work? It should be a solution because it's in the shaded region. So let's test it. Plug in negative 1 with my first equation. Solve it. 1 is less than 4, so check. My second equation, plug in negative 1, 1. 2 plus 4, 6. 6 greater than 0. Check. So yes, this yellow area here is what I'm looking for, and that is the shaded region of both inequalities. So any ordered pair in this graph, shaded in yellow, would be a solution. Now, alright, now it's a little different. We're going to start the other way. So now we start Monday. Alright, so now we're going to be given a graph and we need to write the inequalities for. So the first thing we need to do is, and I want to show a little better here, is that the shaded region is here. So that will help. So we can see by first taking my red, and shading in this area. Okay, so let's start by working with this red line. We need to find an equation. We know it hits our y-axis at 2. So y equals something x plus 2. So we need to find my slope. It goes up 1, positive 1, over negative 2. Up 1, positive 2. Jamal? Alright, so we go up 1 to the left 2. And it's a negative. So it's really going to be y equals negative 1/2 x plus 2. That is the line of my first. I need to decide if it's less than, equal to, if it's greater than, or equal to. So here, test my point, I'm going to test 0, 0. So right now, currently, it says because 0, 0 is shaded in for this, that it is a solution. So this has to be true. So at what point is 0 1/2 times 0? We got to make this true. 0 is less than 2, so this does work. This is also a shaded, so we do not include the answer. So 0 is less than 2. Tells me which way, so I can rewrite this as y is less than negative 1/2 x plus 2. Here's my first inequality. So as you can see here, they found the line as well. They knew the boundary is y equals 1/2 x plus 2, and we found that out. They tested a point, and we are correct. So now let's look at the blue region. This is our shaded area. So our line here crosses at y equals 4. So y equals 4. We need to, it's a dashed line, so we know we have our 4 choices. We know because it's a dashed line that it cannot be either one of these, the equal to, so we have these two options. So let's plug in our 0 value, and we don't have an x, so we just go 0, plug it in for y. 0 is what to 4? Well, 0 is a solution, so this has to be true. So 0 is less than 4. So we're going to use our less than sign. So y is equal to, or y is less than 4 is my other inequality. So I end up using this one here. So this is out. So when you are solving these, first figuring out the shaded region, figuring out the line, plugging in, and deciding whether it's a solution. And remember, you have these 4 choices to choose from. That is all for 7-6 for today.